Now that we have our pseudocode written, it's time to do the all-important task of desk checking. So the purpose of desk checking is to walk through the logic of your program and be sure that everything calculates correctly, everything processes correctly, and that you receive the result that you are expecting. Therefore, you want to process more than one data set so that you can see how the program performs in various situations. You also may want to give thought to what kind of unexpected values might the program encounter. So with this program, for instance, we expect that we'll see a range of normal temperatures, but what if someone enters a negative temperature, someone from a very, very, very cold place? Would our program be able to handle that? So you can see how it's important to take into account what kind of values the program might receive that we aren't expecting it to receive. Along this same line of thought is error checking for input. So, for example, in this case, we're looking at numbers. We're looking at temperatures in numbers. What if a user, for some reason, spells out the temperature? So instead of inputting 80 for 80 degrees, they spell out 80. That's not going to work for our program because the program doesn't know what the word 80 means. It wouldn't be able to use that in a calculation. Now, the error checking side of things and how you would do that it goes a little beyond the scope of what we're doing here, but just keep in mind that that is part of desk checking as well, to consider where a user, by their input, might make a mistake and cause an error, and how you can check from that and prevent it from actually causing a problem with the program, and instead prompt the user to redo their input and give something else. So those are kind of the things that you're looking for when you're desk checking. Primarily for this example, we're going to be looking at the logic. I've put in a couple errors so that you can see how this process will help us determine where those problems are. So I've put your chart here for the temperature range and rating, just as a reminder of what result we want for the rating. So when you're going to desk check, you can create a table like this. You want to make sure to list all of the variables in your program, as well as any output, like a message that you are expecting it to give. Here I've labeled data set 1, 2, and 3. I'm going to do this 3 times with 3 different sets of data. This chart is for my expected results. So I'm going to go ahead and fill this in with what I should receive as a result from this program. Then I will use this chart for desk checking to actually walk through the program and see what values it really does produce. If my expected results and my desk checking results are the same, then my program is free of any logic errors. So I'm going to go ahead and put in some random temperatures. When you're selecting the data set for your initial input values, you just decide whatever values you want to use as an example here. So I'm going to put in 70 and 48, and I'm going to do 91 and 77, and then 78 and 64. Just going to make it. Okay. So basically, these temperatures should give me a result in each of the three ranges. And to calculate that, we will go ahead and just do that on the calculator here. Oops. Plus 48 divided by 2 is 59. And that is following our calculation to add the two temperatures together and then divide by 2 for the average. So our average temperature should be 59. And according to our chart, 59 degrees and lower should give us a rating of cold. That should be the message that will be displayed to the user. For data set 2, 91 plus 77 is 168 divided by 2. That gives us an average temperature of 84, which according to our chart, 80 degrees and higher should give us a rating, a message of hot. And then our last data set, 78 plus 64 equals 142 divided by 2, gives us an average temperature of 71. Our range of 60 to 79 degrees should give us a rating of moderate. So these are my expected results, what I should get from this program. So let's go ahead and proceed with our desk checking and see what our actual results will be. So I can go ahead and put in the temperatures that I have selected for the high temp and low temp, because these are just going to be input from the user, so those will remain the same. Then I'm going to go over here to my program and I'm going to pick up from the input area and continue with the logic of the program. So declare integer average temp. Average temp equals high temp plus low temp divided by 2. So if I wrote this out, we would have 70 plus our low temp is 48 divided by 2. Now, according to the order of operations, the first thing that would happen here would be division. So 48 divided by 2 would be 24. So then I would have 70 plus 24. And then if I added 70 and 24, that would give me a final answer that the average temp equals 94. Now if I compare this with my expected results for data set 1, the average temp should be 59. Clearly these numbers do not match. Now, you probably already guessed exactly what we have to do, but this just demonstrates how walking through the process can help you to identify those errors. So the problem here is that we need to account for the order of operations by putting in parentheses so that high temp and low temp will add first, then the sum will be divided by 2. So now let's try that again. Average temp should equal 70 plus 48 divided by 2. Now if we calculate that, 70 plus 48. And then divide the sum by 2. Now we get average temp equals 59, which does match up with our expected results. Now that we know that the calculation there is correct, we can move on to our output. We know output average temp, that's one of the things we need. And then our if statements determine what our message output will be. So this is the next thing we need to look at because we have comparisons here. So if average temp is greater than or equal to 80, then output the average temperature today was hot. Well, our average temperature here is 59 degrees, so it would not be within this range. Therefore, it will go to the else statement, which includes another if statement. If average temp is less than 59, then output the average temperature today was cold. So our average temp is 59, but with this less than symbol, it means that the temperature would have to be under 59 in order to trigger this output message. So it would go to the next else statement, which is the remaining range, and it would output the average temperature today was moderate. So this would give us a message of moderate. Now compare our output here to what our expected output was. We're getting a message of moderate, but we wanted a message of cold. According to our chart here, the original specifications for the program, 59 and lower should be cold, so it should include the value of 59 degrees. Therefore, we know we need to go in here and adjust our comparison symbol. So to include 59, we would want to do equal, less than, or equal to. So the less than symbol and equals. This will include 59 in the range. So let's go from that step and try it again. If average temp is greater than or equal to 80, then output the temperature was hot. 59 does not fall within this range, so it will move to the else statement. If average temp is less than or equal to 59, then output the average temperature was cold. 59 does fall within this range, so it will output the average temperature today was cold. So our message rating would be cold. Now we're getting the expected message in our actual desk checking. So now we can say that this input was processed correctly. So we found a couple of errors there that we had to correct, and you can see how this process helped us identify those. Alright, so data set 2 is 91 and 77, so let's run through that one real quick. So average temp equals high temp plus low temp divided by 2. So average temp equals 91 plus 77 divided by 2. 91 plus 77, so average temp equals 168 divided by 2. So here we get 84, which was our expected average temp. So that is correct. Then we move to our if statement. Average temp greater than or equal to 80, then output the average temperature today was hot. 84 is greater than 80, so it falls within this range, and the output will be hot. And if we look at our expected results, those are both the same as our expected results, so we know it's correct. Finally, data set 3, we're going to use 78 and 64. So we're going to go through the same process following this calculation. So this time it'll be 78 plus 64. So that gives us 142. And then we'll divide by 2. And that gives us a final average temperature of 71, which is our expected result. Moving to our if-else statement, we have if average temp is greater than or equal to 80, then output the average temperature was hot. 71 does not fall within this range. It's less than 80. So we'll move to the else. If average temp is less than or equal to 59, then output the average temperature today was cold. 71 does not fall within this range, so it will then move again to the else statement. Since it is within the only other range, it will output that the average temperature was moderate. This is our expected result. So again, we know that this is correct. So you can see from this process that it helps you identify any logic errors, and when we compare our expected results with our desk checking, this confirms that with 3 different sets of data, it provides the correct answer, indicating that we have eliminated any logic errors and that it will provide the correct answer in all cases.